Here's an example of using the resistance measurements of a meter here to sort of analyze what it is exactly that switches do. So I have two types of switches here that we'll look at. The one is you can sort of get at the hardware store for under $1 here. It's just the standard on-off switch that you would find in the wall of your house to turn on and off lights. I have this other sort of mad scientist one here from a laboratory that sort of you just sort of open and close like this. And let's just see how they work. So let's start with the mad scientist switch here. If you sort of look at it, you see the switch sort of opens and closes, and if you follow the wires here, it looks like I have a metal conductor right here, and connected to the conductor is a piece of wire that goes up here to this contact of the switch. And so it seems like then if the switch is in this so-called closed position, if there's electrical current, it could travel through this connector, up this wire, across the switch, and then down this connector here, through this wire here, and out this other connector right here. So that's sort of the switching action right there. What you can look at then is I just open the switch. So if I go ahead and put the meter in ohm mode, so I've turned it on, and I have it on the 2000 ohm scale here, but any scale will do just fine. And I sort of press these ohm meter probes into the switch like this. They're held sort of firmly by the spring-loaded action. I just found the switch at a flea market here. Then what will happen is when the switch is open, of course, I'm getting infinite resistance. The meter is overloaded. It sees an infinite resistance. But if I suddenly close the switch like this, push it down to the metal touches, I see the meter drop to 0 ohms here, and that's because now there is an electrical connection between this contact and this one all the way through the metal of the switch here. And if I, of course, open it back up again, we see the resistance goes to infinity. So that's in a nutshell what a switch does. It allows us sort of to break a connection and close a connection like that, and you see that when there's 0 resistance, lights can come on, electricity can flow, and when the switch is off, nothing can flow because there's infinite resistance now. The electricity can't quite make it across this gap. Unless, of course, it was lightning or something at a very high voltage, but we won't be dealing with any of that here. As far as the wall switch goes, you can find at the hardware store for about $1. The two contacts would definitely be these two screws here. So it's a bit more sort of challenging to get these probes in here, but if I'll just sort of stick a probe in there and then I'll just lightly tighten the screw down on the probe like that, just sort of to hold it in there, because it's really convenient just to have the meter leads taken care of so we can focus on what the switch does. And so there you go. So I have the two leads onto the screws of the switch right there, just lightly screwed on. We see the meter is now reading infinity, and lo and behold, the switch is in the off position. Just like the other switches, the lights would be off, but if I switch the switch to the on position, the resistance suddenly dropped to 0 ohms, indicating an electrical connection between this side of the switch and this side of the switch. So internally, inside this plastic case here, is something that looks exactly like this here. You see that we can just make the resistance of the meter change off and on, off and on. And that's what switches do.